Hey everybody, welcome back. Thanks for watching. Today we've got a really neat integral estimate problem. So it turns out if the integral from 0 to 1 of f of x dx is equal to 1, then the integral from 0 to pi over 4 of f of tangent of theta d theta is at least 1/2. So we're going to prove that this is true. So the first thing we want to do, of course, is assume that this quantity is 1, and then we'll show that this is true. So I'm just going to write that. So let's go ahead and assume that the integral from 0 to 1 of f of x dx is equal to 1. And let's investigate the integral from 0 to pi over 4 of f of tangent of theta d theta. Now let's go ahead and do a substitution. So doing a substitution, so one, I'm going to say let u equal tangent of theta. And so before I find du, we know du is going to be secant squared of theta d theta. I want to do a little bit of algebra. You'll see why in a bit. So yeah, let's do some algebra. I want to square both sides and add 1. So square both sides and then add 1. So I get this, but we notice that's a classic Pythagorean identity. I'm doing this because I want to have this on hand for a step from now. So of course we know that's exactly secant squared of theta. Okay, so let's keep that in mind. And so let's also find du. So we know that du is equal to secant squared of theta d theta. But now we can write that in terms of u. So secant squared of theta is exactly u squared plus 1. That'll be d theta. And then I can isolate d theta, right? So du over u squared plus 1 is exactly d theta. So that's going to be helpful. So as of right now, that gives me the following. So I can change my bounds. So this goes from 0 to 1, right? So how do I change my bounds? Theta in for theta, kicks out a u bound. Theta in for theta, kicks out a u bound. So this is going to be f of u over u squared plus 1 du. Okay, so that's what we have so far from our substitution. The next thing we want to do is make a nice little observation. So based on the bounds, we know that u goes from 0 to 1. So I'm going to say observe the following. Okay, so we realize that u goes from 0 to 1. And I'm going to just square each of these. So 0 squared, u squared, 1 squared. And then I'm going to add 1 because ultimately I'm going to want to say something about 1 over u squared plus 1. Okay, so by adding 1, I get one step closer to that. So u squared plus 1, and 1 plus 1 is 2. So just added 1 to everything there. So now I want to take reciprocals. So the reciprocal of 1 is 1. When I take reciprocals, that will switch the order of the inequality. So I get the following. And then the reciprocal of 2, of course, is 1/2. So this proves to be pretty handy. Because if you think about it, and I rewrite this, I have exactly this. But we said that this is at least 1/2. So I can say this is, well, greater than or equal to the integral from 0 to 1 of, we said that's at least 1/2. So I can factor that out. That's the integral from 0 to 1 of f of u du. But we know that the value of the integral doesn't depend on the name u, right? I could call that f of x dx, and that value for the integral would be the same. So that's the same thing as 1/2 the integral from 0 to 1 of f of x dx. But by assumption, this is exactly 1. So this is 1/2. So if I follow this out, this shows that this integral is greater than or equal to 1/2. And that proves our result.